Good morning. This is Professor Grenfell once again with another video for Math 12 Statistics at RCC, Riverside City College. And this is still from Chapter 3, Section 2, so I should make a note of that over here. Okay. And now we're going to continue talking about variance and standard deviation, this time pertaining to sample information. So remember, the notation for that is different. Instead of sigma, instead of the Greek symbol, sigma, we'll use S squared for sample variance, and S itself for standard deviation. Look at that. I don't even really have to abbreviate it as std dot dev dot. I could just abbreviate it as S. That's what that is. That's standard deviation. Now remember this as well. In the equation for population standard deviation, we were dividing by the entire population size. For a sample, the formula is a little bit different. The numerator is basically the same stuff. You just take each data value minus the average. So here we're just calling the average chi bar instead of mu. But the difference comes in here. We have to remember we're doing n minus 1, sample size minus 1, just technicalities. And let's take a look at yet another example of computing standard deviation and variance, right? Here's the procedure. I'll just run through the step-by-step before we talk about the example. So let's just run through. If it asks us for variance and or standard deviation, we have to do all of this. We have to find chi bar. We have to find the average value first. Then we're going to go ahead and calculate these differences. The data value minus the average value for each data value. Then we got to square these one by one. We square them all. And then we add up those values. And then divide by n minus 1. That one would be the variance. If we take the square root of that, then we would have the standard deviation. And so that's what we're going to do for this example. We're going to do that whole process like we had done, essentially like we had done in the previous video. All right, so I'll just scoot the data on down here so that I can copy it down. So the x values are 9, 10, 14, and then 7, 8, 3. The next thing that we have to do is we have to compute the average so that we can take the data value minus whatever that average is. And so in order to get the average, let's take the sum of this. So if I add up all of that, that would be the sum of the x values for a sample. So let's find that sum. All right, sum works out to be 51. And so let's just erase this a little bit. So that means our average, so that would be chi bar in this case because it is a sample, is the sum of the x values divided by the sample size. There we do not do n minus 1. We just do the sample size itself. So that worked out to be 51 divided by 6, and that is exactly 8.5. So that's not too bad. We didn't have to round, and it was a nice decimal to begin with, so these differences will be okay. Let's go ahead and fill all of those in. Okay, and so what? Yeah, we take all of these differences. So the first is what? 9 minus 8.5 gives us 0.5. 10 minus 8.5 again gives us 1.5, and so on and so forth. And notice all of those same positive values are also balanced out by their negative values. So what would this whole column sum up to? 0. But what do we care? 0. We don't care about that, so don't do that. Don't add that up. We're just going to be looking at these values that are not scribble all over them. We're just going to be looking at these values and squaring them, and those squared values are going to be added up. All right, so there are the squares of all of those values. Notice this. When we square everything, these positive values here, and these negative values here, when we square a positive or a negative, the end result is always positive. So this whole sum right here is not going to be 0 like this one, right? But don't even think about that. That doesn't make a difference. This is going to be a positive sum, 65.5. All right, and so there it is. Our formula for variance, S squared, the sample variance, is the sum of x minus chi bar, whole thing squared. For all of those x values, we take the difference of that and the mean and square it and add up all of those, and then we divide by n minus 1. So here we get 65.5 divided by, well, there's 6 items in our sample, and so we're actually going to be dividing by 5. Okay, and so that worked out as exactly 13.1, but that's where we would round it off anyway. We would say round it off to 1 decimal point because all of the data was to the nearest ones. We're going to take it to the nearest tenths. And then the square root of that gives us approximately 3.6. It's 3.61939, and so on and so forth. But again, we round it to 1 extra decimal digit. So there we are. Now I mentioned last time, I don't know if I mentioned it in the last video, but I mentioned in lecture on Monday, or Tuesday or Wednesday, I don't know, this might be for a future semester, who knows. Good morning. Anyhow, so I did allude in class in our lecture to the fact that there is a shortcut formula. Notice here I've got a formula for s squared, and then for s is just taking the square root of the above equation or expression. And notice it looks a little bit similar, but there's some differences, okay? Notice I am not in here or here. Well, there is no chi bar anywhere. So the nice thing is I don't have to mess around finding something that I don't need, okay? If I need to find the mean, then so be it. But if all I need to do is find the variance or the standard deviation, then I'm just going to list all of the x values, find x squared, so just look at those values and square them, sum that x column, and I sum the x squared column. I'll mention what not to do in just a minute with those. We're just creating 2 columns and totaling up each column. And then wherever we see the sum of x, I'm going to take this value and feed it on in. Whenever I see the sum of x squared, those are the squares. Those are adding up the squared values. And so there I'm going to be plugging it in. And so that's the final set of instructions. Plug it in. There you go. So as you noticed above here, we're doing example 3-21, and they say calculate the same thing that we did in example 3-20, but now that we know this shortcut formula, we're going to test it out and try that. So here's the same information. Here are the data. As you can see, I've listed a column for x and a column for x squared. So the first thing to do is just copy down all of the x data, like so. And then after that, go in to the next column and fill in these values. How? Looking at what is in the previous column and squaring it. All right, so there are those perfect squares filled in. Then what do? The next step is to sum up each one of these columns. So the sum of the x column, that was, well, add them all up, we get 51. The sum of the x squared column, those add up to a total of 499. And so what are these? The first one is the sum of the x's, and the second one is the sum of the x squared values. The next thing that we would do is write down the equation, write down the formula that we're going to be using. So we're going to be using s squared is equal to n times the sum of the squares minus the sum of the values squared, all divided by n times n minus 1. So the thing to distinguish here is if we take all of the values and we add them all up, and then we get the result, and we square that whole thing, that is going to be different than taking the values and squaring them and then adding those results all together. Okay? So these are two different procedures, so these will always be different as calculations. So therefore, you should not be plugging in the same value for this and for this. You should be taking, well, let's just go through step by step. So the first thing, n is, in this case, we have a sample size of 6, so that's why I'm substituting in 6 right there. And the next thing that I'm going to be substituting in is this expression right here, the sum of the x squared values. So here I have the sum of the things that I squared and then added them all up. That's the order that this is saying to do it. Square them first and then add them all up. That was 499. After that, we're going to be taking this value and squaring it and subtracting it away. So the sum of the x values is 51. Those are just the values themselves, adding them all up. And then that's going to go right here, and we're going to raise that to the second power. And all of this is divided by, oh, well, that's pretty easy. That would just be 6. Oh, sorry. I colored it in blue, so that would be 6 times 6 minus 1. Without a calculator, we can do that as 5. So now we have plugged everything in to our formula. Basically, the two things that we had to substitute in, well, 3 really. We had to substitute in little n, we had to substitute in the sum of the x values, and then we had to have the sum of the squares of the x values. So notice this, I just wanted to draw it to your attention. You don't have to show this middle step if you don't want to. That when I take the x values and I add them all up and then I square it, the result is drastically different from squaring the values first and then adding them all up. So just watch out for that. And so just continuing on with that calculation, we get 2994 minus 2601 all over 30, which works out to 393 divided by 30. And notice there, that calculates to exactly 13.1 for s squared. Therefore, s itself is the square root of that. I'm not even going to bother writing down square root of that. That is just 3.6. Just like it was last time. So we got the same results as in example 20. And I'll just leave it to you to compare the method by which we did it in example 21 versus example 20. I'm not going to tell you what to think, but I am going to say this is a better way to do it, and I think you should do it like this every single time. It's up to you. I'm not going to tell you what to do. but do it like that every time. Unless they say to do it using that harder, more, whatever, the traditional formula, I would say use this one. Use the one that works better. It's a little bit easier speaking procedurally. And we're going to finish up this video right here. So that was just a short example, a short summary of the difference between the two, well, seemingly different formulas for sample variance and standard deviation.